Hello and welcome to Algebra 1, Lesson 56. In this video, we're going to learn about rationalizing the denominator. All right, so before we kind of move on in Algebra 1, we need to learn what a simplified radical is. Just like when we work with fractions, we always had to simplify it before we reported our answer. We're going to be expected to do the same thing when we work with radicals. So there's three main things you have to do when you work with radicals. So I have here that the simplified form of a radical, and this is kind of the first thing, the radicand, remember that's your number or your variable or could be your expression that's under your radical sign. This contains no factor except for one, that is a. We have perfect square in the case of a square root, perfect cube in the case of a cube root, perfect fourth in the case of a fourth root, and then so on and so forth. So what we're basically saying is that if you saw something like the square root of 8, 8 has a factor of 4, right? 4 is a perfect square. So because this is a square root, this is not simplified because one of the factors of 8 is a perfect square. I could write this as the square root of 4 times the square root of 2. And then the square root of 4 is 2. So I can write this as 2 times the square root of 2. So we've been doing this for a few lessons now, so we already understand this concept. But this goes for higher powers as well. If I had something like, let's say, the cube root of 16, I know that 8 is a factor of 16, and 8 is a perfect cube. So I could write this as the cube root of 8 times the cube root of 2, and then the cube root of 8 is 2, so this is 2 times the cube root of 2. So that's one of the things you're looking for when you're simplifying a radical. All right, the next thing, and we've already learned how to kind of deal with this scenario, the radicand cannot contain fractions, okay? So if you have something like, let's say the square root of 1/4, you've got to split that up and say that this is equal to the square root of 1 over the square root of 4. And of course, this is something you can simplify. Square root of 1 is 1, square root of 4 is 2, so that becomes 1/2. But you can't leave it in this format. The radicand, again, this is the number or the variable or the expression that is underneath the radical symbol, cannot contain fractions when you report your simplified answer. Then there's the last thing here, that is, there is no radical present in any denominator. So we can't have something like, let's say, 2 over the square root of 5, or something like 6 over the square root of 7. They don't want that. That's considered not simplified. So basically the purpose of this lesson is to teach you how to deal with these scenarios right here. We've already learned how to simplify this, and then also kind of the first thing we talked about, which is, pulling out a perfect square or pulling out a perfect cube. So we're focusing on this in this lesson. So what do I do when I come across something like 3 over the square root of 2? Again, we cannot have a radical in the denominator. So this right now is called an irrational number. This is an irrational number. We don't want this. So what could we possibly do to get rid of it? Well, I didn't say that I couldn't have a radical in the numerator. If I just don't want one in the denominator, all I need to do is perform a little trick that we learned back when we studied fractions. I'm going to multiply the denominator by the square root of 2, and I'm going to do the same thing to the numerator. Remember, the square root of 2 over the square root of 2 is a complicated form of 1. Same non-zero number over itself, it's 1. Okay? Now, what happens when I multiply the square root of 2 times the square root of 2? That gives me 2. So the denominator is now a rational number. Okay? It's a rational number. Henceforth, the term rationalizing the denominator. We're taking it from an irrational number and we're making it into a rational number. So again, that's rationalizing the denominator. That's where the term comes from. Then I just multiply 3 times square root of 2. Can't make that any simpler. I just write 3 times square root of 2. Now, the value of this and this is the same. Punch it up on a calculator, you're going to get the same irrational number, but it's just considered simplified to have it in this format versus this one. All right, let's jump through and look at some examples here. And there's some tricks that you need to know when you're dealing with this. It's a very simple process overall. So let's say I saw something like 9 over the square root of 12. Do I want to just say, okay, I'm going to multiply this by square root of 12 over square root of 12? Yes, I can do that, but I'm going to show you in a minute that there's an easier way to do it. So this times this would give me 12, right? Square root of 12 times square root of 12 is 12. And then I have 9 times square root of 12. The problem is here, I can simplify the square root of 12, right? One of its factors is a perfect square, right? 4 is. So I could really write this as 9 times the square root of 4 times the square root of 3 over 12. I know that the square root of 4 is 2. So let's erase this and just put a 2 here. Now, between the numerator and denominator, I could do some canceling, right? If I think about 9 and I think about 12, they each share a factor of 3. So let's cancel this with this and put a 3 here and a 4 here. And then let's cancel between the 2 and the 4 and leave a 2. And basically, I'm going to have a 3 times the square root of 3 in the numerator over a 2 in the denominator. So 3 times the square root of 3 over 2. Now, you can do it that way. We've rationalized the denominator. We've reported a simplified radical. But there's an easier way to kind of look at this. Let's say I erase this and start the problem over. What if before I begun, I simply said, okay, this is the square root of 12. Now, I know that 12 has a perfect square involved in it, square root of 4. If I simplify that before I begin, it's going to lessen my work. So let's put equals 9 over, I can say square root of 4 times square root of 3. And I know the square root of 4 is 2, so let's just put 2 times the square root of 3. Now, because this right here is a rational number, I don't really need to worry about it. All I need to worry about is this irrational number, this square root of 3. So when I multiply now, I'm just going to multiply the numerator and denominator by the square root of 3. And what's going to happen is square root of 3 times square root of 3 is 3. So that's 3. And then you still have your 2 there. So 2 times 3, let me just write it like this, would give you 6. Now, I'm not going to write that out because there's some things we can cancel, obviously. And then we have 9 times square root of 3. So 9 times square root of 3. And then this will cancel with this and give me a 3. So kind of either way I do that, I end up with 3 times square root of 3 over 2. But I feel like if you simplify before you begin, right, if you just attack the problem and simplify before you just start jumping in there, you end up with less work in the end. All right, let's take a look at another one. So we have 2 times the square root of 64 over the square root of 24. So let's simplify. So we have 2 times, the square root of 64 is 8, right? We should know that at this point. So 2 times 8 over the square root of 24, I'm going to write as the square root of 4 times the square root of 6. Now the square root of 4 is 2. So without even doing that, I know I can cancel this with this. Square root of 4 and 2 are the same. So that's gone. So really what I have here is 8 over the square root of 6. And I'm simply going to multiply the numerator and denominator by the square root of 6. And that's going to give me what? I'll have 8 times the square root of 6 over square root of 6 times square root of 6 is 6. And then I can cancel one factor of 2 between numerator and denominator. That's going to give me a 4 here and a 3 here. And so I'm going to end up with 4 times the square root of 6 over 3 as my simplified answer. All right, let's take a look at square root of 5 over 3 times the square root of 8. Again, we want to simplify before we begin. So I know square root of 5, I can't do anything with that. 3 times the square root of 8. I know the square root of 8 at this point is the square root of 4 times square root of 2. So square root of 4 times square root of 2. Then I know this is 2 right here. So let's write this as the square root of 5 over 3 times 2 would be 6. So 6 times the square root of 2. And now all I need to do is multiply the numerator and denominator here by the square root of 2. So the square root of 5 times the square root of 2 is square root of 10 over, we have 6 times square root of 2 times square root of 2. Square root of 2 times square root of 2 is 2. 2 times 6 would be 12. So I get square root of 10 over 12. And again, that's as simple as you can make that. What about something like the square root of 3 over the square root of 7? So I can't simplify either of these. So basically all I'm going to do is look at my denominator. If I have the square root of 7 there, I'm going to multiply by the square root of 7 over the square root of 7. Square root of 7 times square root of 7 is 7. Square root of 3 times square root of 7 is square root of 21. So I get square root of 21 over 7. What about something like the square root of 48 over the square root of 42? Again, I want to simplify before I kind of start rationalizing the denominator. A lot of students just jump right in and go, okay, I want to do square root of 42 over square root of 42. That's going to give you more work in the end, right? You don't want to do that. So let's see if we can simplify this. So square root of 48, I know 48 is 16 times 3. So 16 is a perfect square. So we do square root of 16 times square root of 3. And for 42, I know 42 is 7 times 2 times 3. So no perfect squares in there, right? I got a 7, I got a 2, and I got a 3. So really it's just square root of 42, right? Just square root of 42. So this right here I can simplify. I know that would be 4, so this becomes 4 times square root of 3 over the square root of 42. So now we're just going to multiply the numerator and denominator by that square root of 42. And I know we end up doing that. So you might say, well, why did you go through all the process of, trying to simplify it? It just saves yourself a lot of work in the end, right? You just want to take that extra time and try to simplify, because even reducing this a little bit is going to knock some of your workload down. So if I have the square root of 42 times square root of 42, I know that's going to be equal to 42. So that's my denominator. For my numerator, I'm going to have 4 times the square root of 3 times the square root of 42. Now, 3 times 42 is 126. But if I think about 126, I want you to remember that 42 was what? 42 was 7 times 2 times 3. So you're going to have a perfect square involved in this. It's going to be 9. So I can think about this as 42 times 3. 42 again is 7 times 6. 6 is 3 times 2. So I could really think about this as 14 times 9. So let's write this as the square root of 14 times the square root of 9. And then the square root of 9 is 3. So 3 times 4 would be 12. I'll have 12 times the square root of 14 over 42. And then I've still got some more simplifying to do. 12 and 42 share a common factor of 6, right? So 12 divided by 6 would be 2. 42 divided by 6 would be 7. So in the end, my simplified form is going to be 2 times the square root of 14 over 7. And again, lots of different ways to kind of attack these problems. If you wanted to start out by saying, okay, times square root of 42 over square root of 42, that's fine. You can do that. But I really think if you spend the extra time to try to simplify in the beginning, it saves you work in the end. All right, so now that we've kind of gone through the basic scenarios, and this isn't a very difficult topic, right? We've kind of blown through those. We may be faced now with multiple terms in the numerator or denominator. And we'll cover more complex scenarios in the next lesson. We're going to do a lesson called Further Operations with Radicals, and we're going to cover some more complex scenarios there. So what if you saw something like 7 plus 2 times the square root of 2 over 2 times the square root of 13? Well, this is already pretty well simplified, right? I can't do anything with square root of 13. Can't do anything with square root of 2. Can't add here because I don't have like radicals. So what am I going to do? Well, all I need to do is multiply the denominator here by the square root of 13. If I do that, I'm going to rationalize the denominator. But I've got to do it to the numerator as well. Now, pay close attention here. The main mistake that students make is they'll just multiply this by one of these terms. You've got to use the distributive property and multiply this by both terms that are in that numerator. So, in other words, I've got to have the square root of 13, that's multiplied by 7, and then plus the square root of 13, that's multiplied by 2 times the square root of 2. So, square root of 13 times square root of 2 is square root of 26. So my numerator becomes 7 times square root of 13 plus 2 times the square root of 26. Now, in the denominator, square root of 13 times square root of 13 is 13. So you're going to have 2 times 13 or 26. Simplifying is a little bit more challenging here because remember, we can't just go through and cancel stuff. We've got addition. The biggest mistake students make in Algebra 1 is they start going through and saying, oh, I can cancel this with this. This is 13 now. No, you can't do that. Remember, you cancel common factors. So in order for me to be able to cancel this with something up here, I would have to factor something out for it to cancel. And there's nothing that's common that I'm going to be able to factor out. I can't factor out a 2. This is a 7. This is a 2. So there's not really anything I'm going to be able to do to simplify this further. I just report my answer at this point and say I have 7 times the square root of 13 plus 2 times the square root of 26, and this is over 26. What about if we come across negative 2 plus the square root of 6, and this is over the square root of 22. Again, if I look at my problem and I don't see anywhere where I need to simplify, right? Nothing can be simplified at this point. Well, I'm just thinking about rationalizing the denominator. So I have the square root of 22 down there. So I'm going to multiply the numerator by square root of 22 and the denominator by the square root of 22. And remember, I'm going to multiply this by both terms. So my numerator becomes what? Negative 2 times the square root of 22 plus we'll have square root of 6 times square root of 22. That'll be the square root of 132. And of course, we can simplify that, and we'll do that in a minute. And then this is over. We have the square root of 22 times the square root of 22. That's going to give me 22. Now this right here, you should know, can be simplified. I can't do anything with this one because 22 is what? It's 11 times 2. So there's no perfect square as a factor of 22. But for 132, a lot of you know 132 is 12 times 11. So if I have 132 and that's 12 times 11, 12 is what? It's 4 times 3. So 4 is a perfect square. So I could really write this as 4 times 33. So let's go ahead and do that. So let's say this is equal to negative 2 times the square root of 22 plus 33 times 4. So I'll put the square root of 33 times the square root of 4 over 22. Okay, so now this equals, I've got negative 2 times the square root of 22 plus, I know the square root of 4 is 2, so I'm going to put 2 times the square root of 33 over 22. Now, is there anything I can do to cancel further? Yes, there is. Because in this case, I have a 2 here, and I have a negative 2 here, but I also can think about that as negative 1 times 2. So if I was to factor a 2 out, okay, from each term in that numerator. So in other words, if I said I have 2, and then inside the parentheses I'd have that negative is still there, so negative square root of 22, and then plus, factor the 2 out from there, so just square root of 33, and this is over 22. Now this is multiplication here. 2 is a factor, and this whole thing inside the parentheses here, negative square root of 22 plus square root of 33 is a factor. So now I can cancel common factors. So this can cancel with a factor of 2 down here, and so this is 11, okay? Very important that you understand the difference between when you can cancel and when you can't. Again, that's a very, very common mistake in Algebra 1. So then this equals, what's left in the numerator after I cancel is a negative square root of 22 plus square root of 33 over 11. All right, so let's take a look at a few now with some higher roots involved. Not much more difficult, just a little bit more thinking involved. So if I have something like 10 over the cube root of 4, what do? A lot of people just come through and they go, okay, well, I'm going to do cube root of 4 over cube root of 4. And, okay, 10 times cube root of 4 over 4 times 4 is 16. So this would be the cube root of 16. Now, here's the problem with doing that, particularly when you get into higher roots. This is not simplified. The cube root of 16 is not a perfect cube. This gets broken up into what? The cube root of 8 times the cube root of 2. So this would be 2 times the cube root of 2. I'd still have a radical in the denominator. So this is wrong. This is wrong. Okay? What you need to think about here is, what do I need to do to get to a perfect cube? So, in other words, if I have 4 here, and 4 is 2 squared, well, I need another 2 to get to a perfect cube. So, what I want to multiply by here, in this case, is the cube root of 2 over the cube root of 2. And what's going to happen is I'm going to have 10 times the cube root of 2 in my numerator over 4 times 2 is 8. So this would be the cube root of 8. 8's a perfect cube, so I would get 10 times the cube root of 2 over cube root of 8 is 2. And then I can simplify by canceling a common factor of 2 between here and here. So this is a 5. So my final answer there would be 5 times the cube root of 2. Now, another thing you could have done, and I don't advise this, but a lot of students will end up doing this, you could have just taken your opening scenario and done it twice. So in other words, I can say, well, I've got cube root of 4 there, so I can just multiply this by cube root of 4 times cube root of 4. And I see a lot of students doing this, and I don't know why you wouldn't just do the couple of extra seconds to get the easier calculation. But if you want to do this, you can. It's going to give you the right answer. It's just a little bit more work. So if I multiply the cube root of 4 times the cube root of 4 times the cube root of 4, I would end up with what? The cube root of 64. That's my denominator. And then in the numerator, I would have 10 times the cube root of 16. Now, a lot more work to simplify when you do this. The cube root of 16 is the cube root of 8 times the cube root of 2. So let me write 10 times the cube root of 8 times the cube root of 2. Now, we know this is 2, so we'll simplify that in a minute. The cube root of 64 is 4, so let's write that as 4. Okay, so now I have 2 times 10, which is 20, times the cube root of 2 over 4. So now I've done all that extra work, and I'm going to get the same answer. 20 divided by 4 is 5. So either way, I'm going to end up with what? 5 times the cube root of 2. So again, if you want to do this, you can, but it's going to just take you longer to get the final simplified result in the end. So let me just say this as a rule. I would like for you, as a student, to try to get in the habit of multiplying by the smallest radical possible, because this is going to cut down on the amount of simplification you have to do. That's what you always want to think about. How can I multiply by the smallest radical possible? So let's take a look at one final problem, and I want you to just think about it. Just pause the video and think about what's the smallest radical I can multiply by to accomplish this. All right, so if you've tried this, you would see, okay, you have 6 over the 4th root of 27. What is 27? Just start with that. Well, it's what? It's 9 times 3, and then 9 is 3 times 3. So really it's 3 cubed. Now, if it's 3 cubed, and I have an index of 4, what does that tell you I need to multiply by? One more 3. 3 cubed times 3 to the first power will give me 3 to the 4th power. So that's a perfect fourth, right? 3 to the 4th power is 81. That's what we'd be looking for here as the smallest radical, which would be the 4th root of 3, to multiply by to simplify this thing. So I want to multiply the numerator by the 4th root of 3 and the denominator by the 4th root of 3. And this will equal what? In the numerator, just 6 times the 4th root of 3. In the denominator, the 4th root of 27 times the 4th root of 3 is the 4th root of 81. And I know the 4th root of 81 is 3. So this equals 6 times the 4th root of 3 over, again, this is 3. Now I can cancel here 6 and 3. 6 divided by 3 is 2. So this would be 2. And I end up with what? 2 times the 4th root of 3. Now, again, if you wanted to do this, a lot of students will look at that right there and say, oh, what am I going to do? So they'll multiply by the 4th root of 27 4 times, okay? Please don't do stuff like that. It's way too much work. It's too complicated. Take 5 seconds and build a factor tree and figure out what is the smallest radical that I can multiply by to accomplish this goal. That's going to save you so much work in the end.